Hello everyone, this is Raden Wijaya again. Today I'm going to discuss you about process. What is a process? A process is an instance of a software that is being executed as a running software. So for example, if you have an exe executables just sitting on your drive, okay, when you double click it or you just execute it, it's become a process. Normally between two processes, for example A and B, okay, they cannot share variables. Okay, this process here cannot read a variable here, and this process here cannot read any variables there. Okay, at least that's on modern systems, but on older systems, yeah, it's probably possible, but it's not actually correct way to do it. And today, because we are going to deal with multiprocessing, okay, I'm going to tell you that multiprocessing has about the same problems with multithreading. In order to understand this video, you will need to have certain prerequisite knowledge. For example, you need to understand pointer, linked list, queue. You will need to understand intermediate level of programming logic, intermediate level understanding of C and Linux, and also you'll need to be able to compile with makefile, because if you don't use makefile, the text will be too long, I think. When we can do multithreading, why do we have to make multiprocessing? Simple, because a process is a lot more powerful than a thread. Okay. However, there are certain drawbacks. First, multiprocessing is slow. For example, if you have one process A and you wanna spawn a child process B, okay, you have to copy all the variables. For example, I, J, K, and whatever you have here, you have to copy here. Okay, and this thing is computationally intensive. It's also requires a lot of memory, because you will need to have two different processes. Okay, and then communication between this process and this process is also pretty slow. You can use semaphore, you can use shared variable, you can use queue. It will need to incur some delays. For example, okay, I want to use semaphore. Okay, this will send message to the OS here, and then the OS will send it here. Okay, of course, these are delays. Also, a child process can spawn its own thread. For example, you have a child process here. Okay, you can spawn a thread, one thread, two threads, three threads. Okay, no problem. However, each of the thread cannot spawn a process. At least now, they cannot spawn a process. I don't know in the future, maybe, yeah, I don't know. And process can also communicate with other process. For example, if you have a process that is already running here and another process that is running here, okay, this one's not made by you, okay, and this one is your process. You want them to communicate, okay, you just can give your process whatever semaphore or whatever message available here, okay, and then they can both communicate. And for this program, also multiprocessing, the parent may exit before the child does. It's not good. Trust me, don't do it. For example, if you have a process here, okay, this is the parent, this is the child, okay, the child has not been finished processing, okay, the parent's been finished, okay, the parent may exit. This is quite different to multithreading. However, if you do this, this child will be orphaned, and it may be a hog on your memory. So it's best practice for you to have the child wait, no, sorry, the parents wait for the child to exit before the parents goes exit. In this regard, multithreading and multiprocessing is the same. Mutex must be maintained in order to prevent race conditions. However, there are no built-in functions for mutex in multiprocessing. So you must use semaphore to simulate mutex on your own. The most important function that you use in multiprocessing software is the fork. Why? Because a fork is the function that used to create a child process. Okay, this is for example a process. Okay, and when you want to make a child process, you just fork it. Fork. Okay. Normally, the fork will return with a child PID process identification for the parent's process. So, for example, this is called fork. Okay, this parent thread, the parent process will have the child process identification. Okay, child PID. And here the child process, okay, the child process will return with 0. Okay, fork will return 0 here. So you know, okay, fork is 0, I am the child. Fork is not 0, I am the parents. I will record the child process ID. Parent must record it. Okay, and then we'll have a wait PID. This thing will wait for the process to exit. For example, when you fork these two processes, okay, and at the end of parent process, you must wait the child to exit before the parents exit. Okay, so I have the PID of my child. Okay, I'll just do wait PID for this child. Okay, when this child is finished, okay, is exiting, the wait PID will continue. So wait PID functions like wait. Okay, I'll wait until the child finishes, and then I will continue. It's something like that. Now we come to semaphore functions. Okay, we have semget. Okay, why semget, not semcreate? Because the semaphore is always on the system. Okay, and then when you call semget, the system will assign a semaphore to your process. For example, param1. Okay, this semaphore key is used to communicate with other process. So this key should not be shared. But if you want another process, for example, like process with the other people to communicate with your process, okay, you can share this to this process. Why? Maybe file sharing, maybe, yeah. And then we have the IPC create on param3. Okay, IPC create, not create, no E. Okay, this on the slide is not mistake. And then IPC create, and then you have bar and 0600. 0600 is the unique permission for read and write for that process. Okay, it's private. If you do like something like 660, it means another different process. Maybe other people can also read or write from this process. You can also make it another like 0620. It's just read only. Yeah, standard Unix. And then you must also call this semget before fork. Why? Because after you fork your process, okay, this process 1 and this is child process, okay, this child process will not be able to read any variable on this process, main process, okay, so you have to call this semget before fork. Why? Because that's the reason. This process will have the copy to the semaphore from this. Unless you want to read from file, there is no reason not to call semget before fork. Semctl is a function that is used to control the semaphore. Okay, this thing can read and write the semaphore, and then this thing can also remove semaphore. Okay, on param3 we have the command. It's set value, get value, and ipcrmid. ipcrmid is used to remove the semaphore. Okay, you cannot call the semaphore after ipcrmid. And only when you are setting value, you must fill the param number 4 by set value command. Okay, so semctl, and then enter the semaphore ID, and then enter whatever you want, and then you on param3 you will set value, and param4 you will enter the value. On the source code, however, I don't advise you to call semctl on its own. Always use a function that will call to semctl. Why? Because simple. You will need to call this function in a uniform way, and it's quite long. So just put some automation to the set value and to remove value and to get value. Otherwise, it's very easy to mess up because this thing is quite sensitive. Semop is used to operate the semaphore. Okay, so if you call semop, it will execute the semaphore, and if you don't use IPC no wait, this semaphore will act like pthread mutex log. Okay, it can be configured to pause the execution of your process. And now we come with sem time op. It's simple. It's semop plus sleep. Okay, it's just like, okay, if semop, it will log, it will pause, and then after certain seconds it will continue. Let me get it clear to you. Shared memory is not used to pass information between parent process to child process, or this process to another process. Okay, you should use message queue to pass those information. As usual, you have to initialize this as smget before forking, it will allocate a shared memory segment for your applications. Okay, and the parameters is both the same with semaphore. Okay, param1, it would tell whether it's private or whether it can be shared or it's shareable from another process. Param2 is the size of the data type. This is important. Okay, param2 is the size of data type, so it won't work on array, it won't work on queue. I don't think this thing will work on linked list, but maybe you can try it. And the final parameter is abc create, and we have bar 0600. Actually it's pipe, not bar. Okay, you have pipe to 0600. After you got a segment of shared memory using semget, you must call shmat. This will attach the shared memory segment to your process. Okay, and this parameter of this is the return value of shmget. And then the result from this shmat must be typecast to the same data type that you used in parameter 2 of shmget. If you don't do this, it will not work. Okay, and you have shmgt, it's used to detach the shared memory data. This thing will be called when you are exiting your process. Okay, you don't need the shared memory again, just detach it. And shmgtl, it's used to control the shared memory segment. Okay, you can destroy it by shmgtl ibc_rmad, pretty much the same to the semaphore. Messaging function is actually used to send or receive data between processes. It will add the data on the queue. Now we have msgget. This thing is used to create a message queue. It is not used to get the value from the queue. Okay, you should do it before fork, and msgget requires about the same parameter as shmget or semaphore get. And we now have msgctl. It's used to control and check the message queue. For example, if you want to know how many elements you have on the queue, just do msgctl. If you want to destroy the message queue, also use msgctl. The actual sending and receiving is done by msgsend and msgrecv, msgsend and msgrecv. This thing can only work only if msgget is initialized, but it works best if you send and receive only same data type on a queue. For example, if you have queue A, okay, actually yes, you can send two different types of data types. However, it might not work as expected. So it's best for you to just use one type of data for each queue. In the example application, I will simulate a bank queue. In a bank that have 3 tellers, okay, and each teller is represented by 1 thread, and a queue of customer. Okay, the queue of customer will be done in just 1 thread. So total we have 4 threads. The teller have a working hour. For example, teller 1 will have T1 seconds and teller 3 have T3 seconds working, and we have a customizable time for deposit and withdrawal from customer. Okay, the deposit time is TD and withdrawal time is TW. Deposit and withdrawal process will be simulated by sleep. So for example, when the application, okay, this one is the main thread and this one is the teller thread. Okay, this one queue and give this thread a customer. Okay, and this thread will go to sleep and continue again after it's finished. So when this thread is giving this customer, it will sleep. This thread gives the customer, will sleep. Okay, this thread gives a customer, it will sleep and then will wake up again. The sleeping time depends on the deposit time and withdrawal time. Those with deposit time and withdrawal time is specified on the parameters when the program is run. And the customer will arrive every TC time. Okay, so when the customer is waiting, this thread will sleep as well. So this one 3, it will sleep, and when it wake up, it will send customer. It will sleep and it will send customer. Actually, I can just simply using infinite loop to simulate the customer arrival. However, I think it's just a waste of resource because actually the application is doing nothing. So I think it's better just use sleep. This is the code where the forking happens. On line 5 you can see on the presentation, okay, forks. The result of the fork will be stored on child PID. And then we have a case statement. When the child PID here is 0, it means I'm the child, okay, I'm the child. I don't know my process ID. I can see it on the shared variable perhaps. However, my child PID is not shared on this video. It's outside the scope of this video, but I'm sure you can make it your own. And then when the child PID is not -1, it's not 0, it's whatever it is, okay, the return of the fork is whatever it is, it's not -1, it means the parents. I will then record the child PID. As simple as that. So if I have the child PID, I will know when my child will exit. There is another return from the fork. It's -1. It means the fork has failed. However, I don't put it on this case statement, but it's on the source code, because if I put -1 on this case statement, there won't be enough place on the slide. After all the forking is done, you will come to a simple branching. First, it's the branch for the main process, okay. It will call to a customer method, and after customer method is finished, there is a loop inside it. It will wait for all the child process to exit before continuing by destroying the message queues, semaphores, and shared memories. If the process is a child, it will then execute teller method and then exit gracefully. Customer method is the method that is run by the main process. You can see here we get a simple while loop. It's just reading file, okay, and then it will prepare the customer information, and then it will send message, okay, with customer information. After that it will lock the semaphore, okay, and then it will get message queue number and unlock the semaphore. This will simulate the behavior of pthread condition broadcast. See my previous video about condition broadcast if you need more information. And then it will unlock the semaphore and sleep. Sleep is used to simulate when the customer will come, okay. After the file is read, okay, it will have the wait loop, okay. This is where the wait PID is run. It will wait until each and every child process terminates. The way of receiving message is actually pretty simple. It's a simple do while loop. If the message queue number is more than 1, it means there is a message on the queue, then it will start processing the received message. However, if it is 0, it will then wait until the semaphore receives message. After its wait is done, okay, if the time has elapsed, it will return 2. On the slide, it's not big enough to put all the source code, so I changed the case statement into if statement. Now we'll have to receive get message. It used to check whether there are customers on the queue, and if the result is 1, it will then lock semaphore and will do the processing that it's need. For example, increase the customer number and record the waiting time, and then it will unlock the semaphore, and then it will do the transaction. It will sleep. Afterwards, it will lock the semaphore again and record the turnaround time, and then unlock the semaphore. Now for the exit strategy, it will check. When the result of get message is 2, that means there is no message coming, there is no customer on the queue. It will check whether here is the last teller. If it's the last teller, then the decision to terminate to exit is not here. If it's not the last teller, then the decision to exit will be made here, okay. And then this last line is quite complicated. If this is where we decide if it's the last teller, then if it's time for it to exit. For example, after it's time to exit but there is still customer waiting, the last teller must not be allowed to exit. To help you understand more about how multiprocessing system work, you can take a look at the diagram on this page. Now that this video has come to conclusions, if you have a questions, just drop it on the comments. I'll try to answer it to the best I can. If you feel this video is somehow help you, just subscribe and like. And the source code is, as usual, available on the descriptions. Now, I wish you all the best and good luck in understanding multiprocessing, and don't forget that practices makes perfect. So you have to code, you have to make a system like this on your own, and then you have a complete understanding of how multiprocessing works. Good luck.